So linear first order differential equations follow this type of format. So you have your derivative plus some function of x times y equals some other function of x. So basically what we're going to do to solve this is to come up with a rearrangement that is easier to work with. Okay? And this rearrangement involves something called an integrating factor. And this integrating factor is actually this piece right here. This piece right here. This is called an integrating factor, and it's basically generating this by making the first of all the assumption when r of x is equal to 0 and then solving for y. Okay, and we get this integrating factor here. So that's a key part that we're going to use. The integrating factor, actually, we really don't need to consider the C2. Okay, so as part of the integrating factor, we kind of ignore that C2. Okay, but essentially that's the integrating factor. Now, if we separately look at, and there's no reason why we would do this other than to make it work, right? It's not obvious why we would do something like this, but if we take a look at this and we differentiate this expression with our, product rule. Okay, so we end up with this expression here. Okay. So if you take a look at, if we factor out the integrating factor that we have here, and we end up with this red term here, this red term looks very similar to what we started with up here. So essentially what we can do is we can just replace this with our r of x, and now we have a much simpler form of our equation to work with. So once we have this, what we can do is, well, if we can actually just move the dx over here, and notice that we have a dx term, all x terms here, and a dx. Okay, so we have that dx, and basically we're just differentiating with respect to whatever this complex function is. Okay, so then we can just integrate it, and we end up with that function, and we have this new integral, and we can solve for y. Okay, and essentially we can, this is a form that most people use, but we can actually finish that off and solve for y. So it's kind of complicated how we get this, but essentially we're going to use this formula. So we're just using a rearrangement of a form that we can't solve, which would be this one here, our linear first order type, and we rearrange it into this new type here, and that new type involves an integrating factor.